multiplication of matrices. Let's start out with the dot product. I want to find the dot product of the two vectors. When I say vectors, then either you have a row matrix or a column matrix. Right? So to find the dot product of two vectors, we simply sum in the product of all corresponding entries. So this one is equal to, I can sum, take 2, multiply to 4. Sum, so I add to the second one, which is -1 multiplied to 6. And then the last one, adding 9 times -4. And that would give you the value of -34. May notice that I put that -34 in matrix form. It's 1 by 1, right? It is 1 by 1. Notice that you start out with what? You start out with 1 by 3 times 3 by 1, and you end up with 1 by 1. As long as the inner dimension, when I say inner dimension, I meant this one. I'm running out of color. Let me use purple. Inner dimension is the 2. If they match, you're allowed to multiply 2 matrices together, and then you end up with a matrix with the outer dimension. Just you have 1 by 1 there. Now you ask yourself, where do I use this? It looks weird. Why would I learn this for? Well, for most part, if you study math and you ask yourself, where do I use it? You use it a lot. If not a lot, critical thinking. People who do better in math class, they tend to solve their life problem better. Do you guys go to Costco to eat the food court? I love them. They have the best deal with the most delicious pizza. I think they just try to fish in for customers, right? They're taking a loss at the food court because it's way too cheap for what they just sell for. So the food court serve various meal options: hot dog, sandwich, salad, pizza, etc. Suppose we want to calculate the value of a sale for the hot dog. Last time I checked, $150. $1.50 each. A pizza slice is $1.99, and I think it's come with a drink. But let's just say the drink is 56 cents per 20 ounce. Okay. Here is the sales of pizza, slice, hot dog, and pop on Monday, Tuesday, Wednesday. Those are the numbers of product they sell. I want to calculate the value of a sale for each day. I want to know how much they make on Monday, how much they make on Tuesday, how much they make on Wednesday. So I'm gonna calculate value of sale for each day, right? So first, value of sale on Monday. That's easy, right? You just use your common sense. If you sell in 200 pieces slice, each of them is $1.99. So you take 200 times $1.99, right? Pretty much it. Add in, you sold 167 hot dogs that day, $1.50 per hot dog. And then same thing for the pop, 190 pop, 56 cents per pop. You add them up together, you got $754.90. That's your revenue that day. Now, how do I think of this in terms of dot products? If I would have, so here, for pizza slice is $1.99, hot dog is $1.50, pop is 56 cents. If I would have put the price in vector, let me do, maybe I can do in, doesn't matter. You can do in column vector or row vector. I'll do in, I can do in column. Let me do row so it's consistent with my note. It is the same thing. $1.99, $1.50 and 56 cents. And I multiply with a vector of number of product they sold each day. So on Monday, 200 for pizza slice, 167 for hot dog, 190 for pop. The reason I'm doing this because I need my dimensions to be matched, right? I'm starting out with 1 by 3, and this is 3 by 1. Notice that my inner dimension has to be matched. If it not matched, nothing I can do. Remember the dot product, what do? You multiply each of the corresponding entry and you add them together, right? So remember we take 1.99 times 200 right there. And then what do you do next? $1.50 times 167 right there. And 56 cents times 190. So you actually use it every day. You just don't think of it that way. We don't think it in terms of like how computer do. Right? That's how computer do. That's the red part more like human. And without further ado, is for Tuesday and Wednesday is similarly. So similar computation. For Tuesday and Wednesday.
That's a similar computation. What does that say? Similar what?
I'm a similar computation. So you do the same thing as your Monday, right? So on Tuesday, they sold 189 pizza slice, and they sold 158 hot dogs, and then 150 pops. The price of each of those stay the same, right? $1.99 for pizza slice, $1.50 for hot dog, 56 cents for pop. Just the number of product is different. 189, 158, 150. And then you got some number. I don't know what it is. I didn't calculate it out. You got some number. You know how to do this, right? You take this one, multiply with this one, add into $1.50, multiply to 158. And that. Same thing, same thing you do. $237, 129, 174. Oops. You got some number. And you add them all together, you have a total number of cells. This is explanation. Where do I use that product? That's all. Okay. Now multiplying matrices is more important things. Multiplying matrices. To find matrix product, we complete the dot products. Instead of doing dot product each time, you're gonna do it multiple times when you multiply two matrices. When can I multiply two matrices? It has rule. First, the number of columns of the first matrix must equal to the number of rows of the second matrix. What I meant is the inner dimension are the same. Just like I did here, the inner dimension are the same. If they're not the same, nothing you can do. You just stop. And the result will be what? The result will have the same number of rows at the first matrix, the same number of columns second matrix. It means, so this long sentence means your final matrix dimension is the outer dimensions of the two product matrix. It's like we have 1 by 3 times 3 by 1, you end up with 1 by 1. Right? Let me give you an example. Say I have 2, 3, 4, 5, negative 1, 9, multiply with 0, 5, 4, 9, negative 1, 10, 7, 8. I'm just checking for dimension. I'm not multiplying them, not now. What is the dimension of the first matrix? Yeah, 3 by 2. And then the second one, 2 by 3, by 4. I was gonna just go with 2 by 3. 2 by 4. All the inner match? Yes, right, yes. The inner match. Yes, you end up with what? You're gonna end up with what? What dimension of the matrix? Yeah, 3 by 4. Let me use red for this part. That's what it meant for that slide, that's all. If the inner matrix, I'm sorry, if the inner dimension is not matched, hypothetically, if I have a 4 here and a 2 here, and you stop. You say cannot compute products because inner dimension is not the same. Let's compute this one. Well, before I compute, I gotta check, right? This is 3 by 2, and this is 2 by 3. So yeah, they match. We okay. The procedure is this. It's the dot product. Remember the dot, let me recall. The dot product is what? You take row times what? Row times column, right? Always start out with row times column. Row in the first matrix times the column in the second matrix. Row times column. Maybe I'll use that. And just like the dot product we did, will be what? Negative 1 times 5, right? Negative 1 times 5 plus what? 2 times 4. Do you guys remember the dot product in the first page? First row, first column, first row, second column. You have to finish all of them. Negative 1 times 1 plus 2 times 5. when you break it off into a different column, you don't have any, you don't have any sign in between. This is one entry, this is another entry. First column, first row, third column. -1 times 5 plus 2 times 2. So far, so good. We'll simplify that later. We'll simplify that later. Move on. Second row, first column. Four times 5 plus 2 times 4. Second row, second column. 4 times 1 plus 2 times 5. Second row, third column. 4 times 5 plus 2 times 2. You know that you can end up with 3 by 3 matrix, right? I want you to do the last one. Same thing. I'll walk around see how you do it. Same thing. So, row, column, row, column, row. You already did. You already supposed to. So the last one, this one. Right. Yeah, you multiply, take the first row, multiply with the first column. First row, first column. First row, second column. First row, third column.
Two. So you wrote 3.
Zero times 5. So first row, first column. 0 times 5 plus 1 times 4. 0 times 1 plus 1 times 5. 0 times 5 plus 1 times 2. Now you clean it up. -1 times 5, that's -5, plus 8 is 3. And then -1 plus 10 is 9. And then -1 there. For the blue row will be what? 28, 14, I think I have 24. And then the green one is 4, 5, 2. 3 by 3, like I said, right? Let me show how you do this on your calculator. Of course, on the exam, I have my ways to prevent you from doing that. I can replace letter. I can replace number with letter. Then you have to do that, right? Calculator up. So 3 by 2. You kind of fix the dimension. -1, 2, 4, 2, 0, 1. Make sure you press enter. Once you press enter, you quit to get out of there. Your calculator now, remember matrix A, go back to the matrix, second matrix, go over edit again. You need to input matrix B. Go down B, don't change A, I want to keep A. So highlight matrix B. Dimension is 2 by 3. It's already 2 by 3, so I just input the value. Well, it's already there as well. 515, 452. Second quit, I want to get out of there. So far, so good. Now you have 2 matrices inside your calculator. Go back to matrix, second matrix, names, matrix A first, press A, and then second matrix again. Put your cursor down to matrix B, press enter. You see that AB? Press enter again. That's your answer. That's what we had, right? I want you guys to try this one on your own. I'll give you Sorry, I got kicked out.
So 2 by 2. And then the result. So this is the result. One times 1 plus 2 times 5.
I would recommend you start out with the matrix first, the dimension, because sometimes you don't even, you can't even do anything, right? 2 by 2 is 2 by 3. It did match. Well, you're gonna end up with what? You're gonna end up with 2 by 3, right? Something like that. Mean 2 row, 3 column. 1, 2, 3, 1, 2, 3, something like that, right? So you have an idea. Equal. First row, first column, always. 1 times 1 plus 2 times 5. First row, second column. 1 times 2 plus 2 times 0. First row, third column till you finish the whole second matrix. 1 times 1, oops, sorry, 1 times 0 plus 2 times 4. Second row, first column. Negative 1 times 1 plus 4 times 5. Negative 1 times 2 plus 4 times 0. Negative 1 times 0 plus 4 times 4. And you clean that up. Now you have 2 by 3, you're done, right? 11, 2, 8, 19, negative 2, 16. You can check with your calculator, okay? And please remember the procedure because on the, now the reason I show you how to use calculator because later on for the application problem, I'm not gonna make you do this, right? All I need you to construct what? System equation, put it in a matrix form, and then solve using calculator, right? But for now, for the baby step, you need to know how to do this. Because on the exam, I may have something like this. I can chain. Instead of giving you number, I can change it to letter, right? You cannot use calculator for that. So you still gotta know how to do it. Identity matrix. Now, in number, identity number will be number 1, right? It's just real number. For matrix, the identity matrix is the matrix equivalent to the number 1, but the diagonal will be all 1. Everything else is 0. Matter of fact, let me give you some bullet points about identity matrix. Identity matrix is a square matrix. The one that you saw, the one that you see there is the 3 by 3. It could be 2 by 2, 4 by 4, right? Come on. The rest of the entries are 0. Another property of identity matrix, which is very important, if in on real number, 3 times 1 is the same thing as 3, right? For identity matrix, if I take matrix A times identity I is still equal A. Of course, assume that A and I have a match in the matrix. Example, find matrix B such that AB equal I. let's write down matrix A. Matrix A is 3, 1, negative 3, 3 times matrix B. I don't know what dimension to be. Okay, I just leave it like that for now. Equal I. Now matrix A is 2 by 2. You know that. The final matrix is 2 by 2. What is the dimension of B? Yeah, 2 by 2, right? First of all, the inner dimensional has to be matched, and what else? And you have to end up with the same with 2 by 2, so that 2 right there should be 2 here as well, right? Which is coincident is 2 by 2. Sometimes I can change, right? If the on the right hand side, if it's not I, if it could be something else, this doesn't have to be 2 by 2. It could be 2 by something. I'm gonna call, because I don't know the entry of matrix B, I'm gonna call that's A, B, C, D, like that. On your quiz, I give you a system of equation and then ask you to convert to matrix. Now I give you matrix, I want to convert it back to system of equation. Using matrix multiplication, first row, first column. 3 times A plus 1 times C. First row, second column. 3 times B plus 1 times D. Now you've done second row, first column. Negative 3 times A plus 3 times C. That's what I meant by having letter. Negative 3 times B Sorry, Zoomer. I kept being kicked out. Let's solve them. The reason I'm combining 1 and 3 because what? They have the same variables, right? A and C. Can you solve for that? 1 and 3, can I add them together? 3a plus negative 3a is 0, right? So c plus 3c, that's 4c. 1 plus 0 is 1. This implies c equal 1 over 4. Now you plug in c into equation 1. Number 1. Three a plus 1 4 because c is 1 4 equal 1. Let me give you a happy ending. A equal 1 4 as well. Has to be right. 3 4 plus 1 4 is 1. So it has to be 1 4. I got C. Now I have to solve for B and D. For B and D, we're going to use equation 2 and equation 4. They already opposite. B is opposite. All you do is add them together. You got 4D equal 1. D is 1 4. Plus 1 4 into equation 2 or equation 4, doesn't matter. Three B plus 1 4 equals 0. B equal negative 12, negative 1 over 12. Final answer. Remember, you're trying to look in for matrix B, right? A, B, C, D, E. All you have to plug it in. Let's see. A is 1 4. B is B is negative 1 over 12. C is 1 4. D is 1 4. That's it. Done here. We done here. Yeah. Sorry about the technical issue. Right. If nothing else, bye Zoomer. I'll see you again on Friday.
Thank you.
You're welcome. Thank you.
Have a good day.
Friday. Good day. You too. Bye bye. Let me keep up. Right, a quick question. Give me a second. I don't know how to access from here. Oh, stop share. Oh, there we go.